And in section 8.2, we'll be talking about what's called the law of cosines. Now I know what you're thinking. There is no law of tangents. We have the law of sines and we have the law of cosines. And we use the law of cosines if we have a problem where it's like a side angle side and we can't make a full fraction, or if we have a side situation and we don't have any angles. Now the main purpose of the law of cosines is to get us to the law of sines. In other words, if you can't do the law of sines because you're missing a piece of the fraction, we use the law of cosines to get that missing piece. So let's talk about what the law of cosines is. To find a side, we use one of these formulas. A squared is equal to b squared plus c squared minus 2bc times the cosine of angle A. B squared would equal a squared plus c squared minus 2ac times the cosine of angle B, and c squared is equal to a squared plus b squared minus 2ab times the cosine of angle C. What we could do is, if we're given side B and side C, we could just plug those in. We'll need angle A, and then we could figure out what side A would be. Now what we could do is we could rearrange one of these formulas. So take this, and let's say we want to find an angle. Meaning, what if you're given three sides and you need an angle to do the law of sines? Well, let's just take one of these and we'll see if we could find a pattern. You don't have to write this down. I'm going to erase this in a second. But we have a squared is equal to b squared plus c squared minus 2bc cosine of A. So let's try to get the cosine of A by itself. I'll subtract b squared and c squared. So we get negative b squared minus c squared plus a squared is equal to negative 2bc cosine of angle A. And then we could divide both sides by negative 2bc. And we'd get that the cosine of angle A is equal to, well, if we distribute that negative to the top and bottom, we would get b squared plus c squared minus a squared over 2bc. So this is maybe like a little, aside here. That's the work to come up with a formula for an angle. So that's the work. I'll leave that there actually in case you're curious where it comes from. But if you ever have to find an angle, let's use that formula, that the cosine of angle A is equal to the other two sides minus the side of that angle divided by 2 times the other two sides. Similarly, the cosine of B is equal to a squared plus c squared minus b squared over 2ac, and then the cosine of C would equal a squared plus b squared minus c squared over 2ab. So now we're all ready to try out some examples. One thing I just want to point out with the law of cosines is once in a while you could wind up with an extraneous solution, meaning you do all the math right and the answer doesn't make sense. The way that we minimize the chances of getting into one of those extraneous solutions is we always try to find the largest side or angle first. And then you just want to check. Make sure that your largest side is opposite your largest angle. And make sure that your smallest side is opposite your smallest angle. That would, happen if you get an answer and it's not quite the right approach. You didn't make a mistake, it's just, it happens once in a while. I'd say maybe once out of 10 times. So let's do a couple examples like this. Let's try a problem where we have side angle side. So what if the problem looked like this, where side B was 5.8, side C was 3.6, and angle A is 39.5 degrees. Now I always recommend we draw out the triangle just to give us perspective on what we need. Angle A is 39.5. We know, well, we don't have any other angles, so we could just pick where B and C go. Side B is 5.8 and side C is 3.6. So we're not going to be looking to see how many triangles there are. In order to do that, we need to have a side, its angle, and then another side. But we talked about that in the Law of Sines section. Okay, so we can't do Law of Sines because we don't have a full fraction. If you try to do it, we know angle A, but we don't know side A. We know side B, but we don't know angle B. We know side C, but we don't know angle C. So we don't have a full fraction. All right, so we do know angle A though, so let's figure out what side A is using the law of cosines. Using the law of cosines, A squared would equal B squared plus C squared minus 2BC times the cosine of angle A. Well, B was 5.8, C is 3.6. I'm going to type this in, and let's see what we get. Let's just type it in one shot. We don't have to do it in pieces. So 5.8 squared plus 3.6 squared minus 2 parentheses 5.8 parentheses 3.6 times the cosine of 39.5. This comes out to 14.37 whatever. Let's figure out the exact answer by typing into our calculator the square root and then second negative sign. That takes the square root of the exact number we just found, which is 3.8. So now side A is 3.8. Now we do have a full fraction. We could write 3.8 over the sine of 39.5 and set that equal to, well, we could either find angle B or C. It doesn't matter which one. I'm just going to pick B, cross multiply and divide, and let's see what we get. I'm getting that the sine of B is equal to 5.8 times the sine of 39.5 divided by 3.8, and that comes out to 0.97, whatever. I want to take the inverse sine of both sides. And if you do that, the inverse sine of second negative tells us angle B is 76.1 degrees. Okay, so now I'm going to do 180 minus 39.5 and 76.1. And that equals 64.4. And that would be our answer. Let's just double check and make sure our largest angle is opposite the largest side. Largest angle, largest side, smallest angle, smallest side. Okay, so that's a problem. We have a problem here. Notice that A is the smallest angle, but side A is not the smallest side, 3.6 is. So this is actually an extraneous solution. So how could we get around this? Well, we can't help but get side A. Side A is fine. So this is good. This is good. These two aspects are good. But you remember how over here I told you we could either find angle B or angle C first? I found the angle B first, and that was a problem. So instead of finding angle B, let's see if we could find angle C first. So we'll do 3.8 over the sine of 39.5 is equal to we'll get angle C first, so that's 3.6 over the sine of angle C. Cross multiplying, and then dividing by 3.8. Let's see what we get. Clear this out. So 3.6 times the sine of 39.5 divided by 3.8 comes out to 0.602. And if we take the inverse sine of both sides, we get that angle C is 37.1 degrees. Okay, so if angle C is 37.1, let's figure out what angle B is, and then hopefully the biggest angle is opposite the biggest side, smallest angle is opposite the smallest side. So I'm going to do 180 minus 37.1 minus 39.5, and that comes out to 103.4. And let's just make sure everything's good now. Largest angle, largest side, smallest angle, smallest side. So that checks out. So you could see an example where you have to check for extraneous solutions. And we did. So we, instead of finding one angle, we went for the other angle, and everything works out well. All right, let's do one more example, but instead of having a side angle side, let's do one where it's three sides, and we have to find an angle. So what if we knew that side A was 3.8, side B was 9.6, and side C was 7.7? I'll just get my triangle set up. And clearly we can't do law of sines because we don't have any angles. So we have to figure out what one of the angles is using law of cosines, and then we could use law of sines to finish this. All right, so when we were talking about law of cosines, I asked you to always find the largest side first or find the largest angle first. In this case, it looks like it would be angle B. So according to our formula to find an angle, we're going to find the cosine of angle B. That would equal a squared plus c squared minus b squared over 2ac. So the cosine of angle B is equal to 3.8 squared plus 7.7 squared minus 9.6 squared over 2 times A times C. Now, it could get a little tricky to type this into your calculator. You don't want to do this all at once. Let's just do a numerator and then we'll do the denominator. So 3.8 squared plus 7.7 squared minus 9.6 squared. This comes out to negative 18.43. And then we'll do our denominator. 2 times 3.8 times 7.7 is 58.52. So if we want to figure out what angle B is, we have to take the inverse cosine of both sides. So I'm going to type into my calculator inverse cosine, negative 18.43 divided by 58.52. My calculator is telling me this is 108.4 degrees. Now what we could do is law of sines to finish this. Now we have the option. We could either get angle A or angle C. So it's pretty much a gamble, if you don't get an extraneous solution. But let's go with angle A. We'll check, and if we get an extraneous solution, we'll go back and we'll get angle C first. So we have a full fraction with the b's. We have 9.6 over the sine of 108.4, and we're going to set that equal to 3.8 over the sine of angle A. So 3.8 cross multiply times the sine of 108.4 is equal to 9.6 times the sine of A. We'll divide both sides by 9.6. And we get the sine of A is equal to 3.8 times the sine of 108.4 divided by 9.6. Comes out to 0.375, but we're not going to round that. We're going to ask our calculator to take the inverse sine of that actual answer. So on my calculator, I'm just going to hit inverse sine, second negative, and it tells me that angle A is 22.1 degrees. And to figure out angle C, we do 180 minus 22.1 and 108.4. Let's see what that is. 180 minus 22.1 minus 108.4 comes out to 49.5 degrees. And let's check to make sure the largest angle is opposite the largest side, smallest angle is opposite the smallest side. So this would be our solution. Everything checks out, and that's it. Thank you so much for your attention. Have a nice day.